Good day, grade 12 learners. Welcome to today's mathematics lesson. This lesson is brought to you by the Free State Department of Education in collaboration with Hagama Research and Development. My name is Annelen Sindane. We are doing our final revision today for paper 2. Please, I will ask you and urge you, paper 1 is done. Do not entertain the memos that will start circulating, discussing questions of paper 1. Let's focus on paper 2 because what's done is done. It won't change. So do not be tempted this weekend. Don't do any paper 1 things. Just focus on paper 2 things because we can still change the mark we can get in paper 2, but we can't change the mark that we have gotten in paper 1. So let's focus on paper 2. Now, our topics for today is trigonometry, and we know that trigonometry has 50 plus minus 3 marks, and Euclidean geometry has 40 plus minus 3 marks. So remember, we did revision of statistics as well as analytical geometry before our exam started. Please just go through those lessons again to help you prepare thoroughly for those 2 sections. If you check, these 2 topics account for 90 marks in our exam, and the other 2 topics account for 60 marks. Therefore, we can do our best to get these marks. Now, this we've already discussed, and I want us to move on to our target setting. Remember, our focus is there and there. For you to get a bachelor pass, you must get at least 100 marks in paper 2. And for you to get a level 3, you must at least get 68 marks in paper 2. So let's target correctly. You can see that if you can get 15 marks for statistics, you are able to get a bachelor pass. If you get 25 marks out of 40 marks, there, it's good. Trigonometry, you aim at getting 35, and for Euclidean geometry, you aim at getting 25 marks. And it's possible, learners, we can do it. Now, we have been practicing a lot, and all it needs us is to just focus our practice. Where we are able to get all the marks, we practice less of those questions, and where we are getting less marks, that's where we should put our attention on, and on those sections that keep us dropping us down, that is where we should focus. The question papers always have memos. Please answer the question, timing yourself on time management. It's always 1.2 minutes max, 1.2 minutes per mark. So if a question is 5 marks, you must use at least 6 minutes or less so that you are able to complete all the sections of the question paper. Let's move on. Our information page, please, let's always refer to it so that we do not write wrong formulas. These are mostly focusing on paper 1, and for paper 2, we normally use these. For statistics, our analytical geometry, that is the formula that we normally use. And for Euclidean geometry, we have our compound angle identities or formula, and then we have our double angle identities, and then we also have our area rule, cosine rule, as well as our sine rule. We should be able to use these and focus on this. Now, we'll start by looking at trigonometry. We know our SOHCAHTOA, we've been using it. Remember, trigonometry is about triangles and angles. So sine of an angle, it's always the y over r. We are now referring to the Cartesian plane, and we know that's what we are using to find our angles. If our angle is in the second quadrant, it can be in the third quadrant, or it can be in the fourth quadrant. we should be able to draw our triangles. We always draw our constructions vertically. We do not do horizontal constructions. So if this is our point, this is our hypotenuse, this is the opposite. Remember, our angle is that one there. That's our angle theta. We start from the origin in an anti-clockwise direction like that. Now, we know that all of them are positive in the first quadrant because our x and y in the first quadrant, x is positive, y is also positive. In the second quadrant, x is negative, y is positive. That is why only sign is positive. In the third quadrant, x is negative and y is negative. In the fourth quadrant, our x is positive and our y is negative. That is why only cos is positive there. Tan, it's because it's a negative divided by negative. It will always give us a positive. Now, in the first quadrant, we normally deal with theta, or we are dealing with 90 minus theta. In the second quadrant, 90 plus, remember, it's 0, 90, 180, 270, 360 degrees there. And then if we are moving in the anti-clockwise direction, we are dealing with negative angles. So remember, negative 90, negative 180, negative 270, then we come back to 0 or negative 360. And then we know that 90 minus and 90 plus, I will not deal with 270 minus and 270 plus, but if you are comfortable with it, please use it. If you won't miss, because in most cases some get the cofunction and miss the sign, hence I don't like using 270 as well. So sine becomes cos if it's 90 minus or 90 plus, and cos becomes sine. We should be able to do those cofunctions. Moving forward, I'm just adding flesh so that you are able to see how the angles are in which of the quadrant, which one is theta, which one is 360 minus theta, and you are able to see that. So our reduction rules, we know that the reduction of sine 90 minus theta is cos, cos 90 minus is sine, cos sine 90 plus is cos, and cos 90 plus it's negative because cos is negative in the second quadrant. That's why that one becomes negative sine. 180 minus, we know those ones. 180 plus, we know them. 360 minus, and then our negative angle reductions, we have them there. And then we have, whenever we have an angle which is greater than 360, we subtract 360 until we get an angle between 0 and 360 degrees. Then we are able to apply our reduction rules and our identities. The square identity, cos squared theta plus sine squared theta is equal to 1. We use it a lot for our cast diagram. Tan is sine over cos. We must know that identity as well. And then we have that question which I will ask you to answer quickly. I'll give you 5 minutes to attempt that question. Welcome back. So we are given sine 36 as square root 1 minus p squared. So this one, it's in terms of a variable. So remember sine, we said it's y over r. So we have the value of y. So we can write this as square root 1 minus p squared, all this over 1. So we have our r, hence in our diagram, our job is to find x, and we'll have square root 1 minus p squared there in terms of coordinates. 36 degrees is in the first quadrant, 0, 90. It's between 0 and 90, then we get that. From there on, we are able to apply our theorem of Pythagoras because we know that tan 36 degrees becomes y over x. Y we have, so our job is to find x. We apply the theorem of Pythagoras and we should get our answer as such. By applying theorem of Pythagoras, we are saying our r squared, which is 1 squared, is equal to our x squared plus square root 1 minus p squared all squared. When we simplify this, we'll get 1 minus 1 minus p squared is equal to x squared, because the square root is gone by squaring, and this will give us x squared is equal to p squared. Hence our x will be plus minus the square root of p. But because we are in the first quadrant, we know that our x value is positive, hence we take the positive value and we get our answer as such. We have to find cos 108. Now, please, we have to be careful here. Cos 108, we can use our reduction. It's above 90 degrees. So when we reduce cos 108, we get negative cos 72. And we know that there's a relationship between 36 and 72. 72 becomes 36 times 2. And we know that this is an identity, a double angle identity, which we can use. We can write it as 2 cos squared 36 minus 1. And our cos 36, we know that it's p over 1. So where there's cos 36, we put p and we square it, and we get negative 2p squared plus 1. We get our answer, reduction, double angle, using the correct identity, substituting and getting our answer, we get our marks there. Now, we have the second activity where we are simplifying without using a calculator. It's important to always follow our instructions. To a single trigonometric ratio, we are able to see that the reduction of sine 140 degrees, you write it down, it becomes positive sine 40 degrees times the reduction of sine 360 degrees minus x. We know that this will be negative sine x. Cos 50 for now, we can leave it. Tan negative, it's negative tan x. When you look at this, you already have 1, 2, 3 marks by simply doing that. You can see I'm doing my reductions in brackets to take care of my signs. It's encouraged. So we are able to get that. So if you want, you can now change sine 40 to cos 50 if you want, or we know that cos 50 is the same as sine 40 using our cofunctions. So you get a mark for that. From there, we know that tan becomes sine over cos, and this will give our answer as such, and we'll get our answer as cos x. You can't leave your answer as sine over tan. You can further simplify that. Hence, we say to a single trigonometric ratio. That's how we get our 5 marks. Moving forward, we have to prove the identity. We prove that the left-hand side is equal to the right-hand side. in the interest of time, we are going to do this one together. We have sine and cos. So our main job is to make sure our answer has cos as well. Let's try and make sure that the numerator is in terms of cos. This one, it's 540 minus. We subtract 360, it will be the same as saying cos 180 minus x. Remember, we can reduce this. So using that, I'll substitute where I have sine squared, I will put 1 minus cos squared x plus cos x over the reduction of cos 180 minus is negative cos x. We have 2 marks now. So moving forward, this simplifies to that. For simplifying to get that stage, we factorize and then we simplify to get our both factors there, and then this will give us our 2 cos x minus 1. It must come at the end. As you can see, it comes out. We get our 5 marks there. Moving forward, let's look at compound angles for our trigonometry. You see, I have alpha and beta. This can be alpha plus beta. We are able to see that. Those will give us those 2 identities. And then we have alpha minus beta. So if this is alpha, the whole angle here is alpha, and this small angle here is beta. We want that small piece. This becomes alpha minus beta, which will help us use those 2 identities there. Cos minus and sine minus. And then we also have where we have double angle identities, alpha plus alpha. We know that this will now give us our double angle identities, and that will give us sine 2a is equal to 2 sine a cos a. Cos 2a has 3 different identities that we can use. Cos squared a minus sine squared a, 1 minus 2 sine squared a, and we also have 2 cos squared a minus 1 as the identities for our double angles. So we must be able to use these identities to simplify and prove. I will give you 5 minutes to answer 6.11 and 6.12. welcome back. I hope you were able to solve this one. Now, remember, we have to show that cos alpha, we have to derive the formula for cos alpha minus beta. Please, if you have to derive, you use what you are given. So, for me, from my algebra, I know that I can write this one as cos alpha minus negative beta, because negative and a negative gives me a plus, so I haven't changed. So it means where there's alpha, I'll substitute alpha. Where there's beta, I'll substitute with negative beta, because I have to show how I get to the final answer. I can't just write from the formula page that cos alpha plus beta is cos alpha sine beta minus sine alpha sine beta. I can't use that. So let's move on and see. This is what we do. For that, we get a mark, and then we substitute, and then we do the reduction. We get our negative beta, then we write our formula there. We move on to the next one. 6.12, simplify completely 2 cos 6x cos 4x minus cos 10x plus 2 sine squared x. I will encourage you, if you check here, I have 6x, here I've got 4x. It means, let me check the relationship between these two. 6 plus 4 gives me that 10. So I can split this 10 into 6x and 4x, and then apply my compound angle identities. This one, for now, we just leave it. We will deal with it at the end. Don't change it into 1 minus cos squared, otherwise it will give you a challenge. So, but it will still give you the answer, but it becomes too long for 5 marks. Otherwise, you'll be doing a lot of changes, and the amount of working that you will have becomes more. Deal with the 6x and the 10x first. This one, it's already a bit simplified. You can deal with it at the end. So we will get that. I change cos 10x into cos 6x plus 4x. So from there on, this will give us 2 cos 6x cos 4x minus cos 6x cos 4x minus the expansion of a plus, it's a minus there. You are going to use it there. And then from there on, these are like terms. Negative and a negative will give us a positive. And we get cos 6x cos 4x plus sine 6x sine 4x plus 2 sine squared x. Now, from there on, we know that this, it's a cos, sine, sine, and there's a plus. So this is the same as saying cos 6x minus 4x, which will lead us into cos 2x there. But we know that cos 2x is a double angle identity. We then use the one identity that has sine. There are 3 of them. We have cos squared x minus sine squared x. We also have 2 cos squared x minus 1, and we also have 1 minus 2 sine squared x. So the one, because these are additive inverses, they will give us 0, so it's safer to use this one. Otherwise, if you use 2 cos squared minus 1 and then you substitute it here, you will need to substitute for cos 1 minus cos squared there, then the algebra becomes too much. So let's simply substitute there. We get 1 minus 2 sine squared x plus 2 sine squared x, and this will give us an answer of 1. We get our answer there. So for identifying, expanding, simplifying, and getting our identity there as 1 minus 2 sine squared x, and then getting our answer as 1, we get our 5 marks. Moving forward, we also have to solve trigonometric equations. Remember the types. We have the one where we will have our solution, and we are saying there are equations that form. We have the tan type where I have sine x is equal to 4 cos x. We are able to simplify this. We also have the type which is quadratic, and we also have the type which requires us to use the cofunctions, where you are given sine 2x is equal to cos 90 minus x. Or you have it, so from there on, you use your cofunctions. This will be cos 90 minus 2x. You make one of the angles your reference angles, then you solve. We move on. So remember, when we simplify our trigonometric ratios, we end up having those as angles sine x equals, tan x equals, or cos x equals. How do we move from there? Remember, the sign just indicates the quadrant where our solution lies, and then from there we find our reference angle. We ignore the negative sign if it's negative. We find our reference angle and we apply our reduction rules. If it's in the third quadrant, it means it will be 180 plus whatever we got as our reference angle, and we'll get that as 210 plus k times 360. Remember the k times 360, this is the period of our function, and we always have to write k element of integers because we can either move in the negative or positive direction. The alternative, which is known as the graphical method, explains this further, where we know that our sine function is between -1 and 1, our cos function as well. So from there on, we find our reference angle and we get our solution in quadrant 1 and quadrant 2. And then we also have our cosine function where we use plus or minus the cos of that angle, and we always write k element of integers. It shouldn't miss in our solution for the general solution. So when they say find the solution in a given interval, you substitute your integer values and then you get the one that will fall in the given interval. And then we have the period for tan. It's 180 degrees, and then we just theta will be shift tan of A, and then we get our plus k times 180 k element of integers because the period for the tan function is 180 degrees. We have to determine the general solution of tan x is equal to sine 2x, where cos x is less than 0, and that question is 7 marks. How do we do it? So I'll give you a hint and then give you 5 minutes to finish it up. We know that tan is an identity, sine 2x is an identity, then you move from there. I'm giving you 5 minutes. Let's answer. Welcome back. Now remember, I said for every mark it's 1.2 minutes. So where you can move fast, I am trying to make you try to manage your speed so that you are able to cover all sections of the question paper. Otherwise, if you take too much time on one question, you will not be able to finish the question paper. So I am saying, so for getting that identity and that identity, you get a mark. From there on, you move everything to one side. Please, we do not divide by a variable. We can't divide by sine x. But what we do is we move everything to one side and we factorize. Common factor is sine x. We get 4 cos squared is equal to 1. So that's standard form. We factorize and then we get our sine x. So cos squared, but remember the condition where cos is negative. So where cos is negative, we are taking only the solution when cos x is equal to negative half, not when it's positive 1/2. So from there on, we find our solution, 180 plus k times 360. And then we also have our solution in the second and third quadrant. We get a mark there. And then we get a mark for k 360 degrees, k element of integers. That's where the 7th mark goes. Now the alternative, we can use that one as well. It works. But instead of cos squared, we can substitute with 1 minus sine squared, and then we have the identity that, and we get our solution. Remember, examiners can do anything with these questions. They can ask you to show that tan x minus 2 tan x is equal to 3 sine squared minus 4 sine cubed x. So we should always be versatile and be able to see what we are supposed to do there. Take out a common factor, sine x, we remain with that, and then we use our sine squared, and then we know that this is the square root. Sine x is equal to plus or minus the square root of 3/4, and that will give us that, or it will give us our solution as that one. And then from there on, our function does not have cos, so where is cos negative? We know. We will have this in quadrant 2 and quadrant 3, and then we get that, and then we get quadrant 2, sine is positive and cos is negative. We get our solution, as well as in quadrant 3, because cos is negative and sine is also negative in quadrant 3. We get our 7 marks. Moving forward, let's talk about trigonometric graphs. So for our graphs, we look at amplitude, which is the distance between maximum and minimum y values. How do we get the amplitude? It is half the distance between the maximum and the minimum y value. Your y value at a maximum and your y value at a minimum. So maximum minus minimum, we divide it by 2, it gives us the amplitude. It should always be positive. Our vertical shift, when we have plus q, if it's negative, it means our graph shifts. Those negative units down. If it's positive, it's those units up. If it's a plus 1, it's 1 unit up. If it's a plus 2, 2 units up, something like that. Period shifts. If our sine is equal to x, and then the next one, its sine is equal to 2x, the period changes. Remember, a period, it's what it takes to complete a cycle. So for our sine, it has to start and end. That's a complete cycle. And then we will have our period. If sine is 2x, our period is 180 degrees. If we have y is equal to cos 3x, the period is 120. If I have tan 4x, remember the period for the tan function is 180. We divide it by 4, we get a period of 45 degrees. Mixed shifts, it's when we have the amplitude changing as well as the period changing. Sometimes also our vertical shifts can occur as well, and our horizontal shifts. Horizontal shifts, we are saying it's cos x plus. If it's a plus, it shifts p units to the left. If it's x minus p, it shifts p units to the right, as illustrated on the right hand side. So we can have those shifts. And then we are saying our sketch of our graph, we must be able to draw the original function for sine in a given interval, and then you compare what has changed. But if our a changes sign, our graph flips about the x-axis. So whatever is positive on the original graph becomes negative on the rotated graph. Our amplitude remains as A, and our tan graph does not have an amplitude because remember it's continuous. It has asymptotes, and then our period we divide by k, and then sketching a graph. For example, if I have 2 cos 3x plus 1, I'm able to sketch the graph of 2 cos 3x, finding the period is 120, and we are able to draw the graph. And then plus 1, we know that it will have a maximum at 2 because of the 2 here, and a minimum at negative 2 there, negative 60 and negative 2, 0 degrees and 2. And then from there on, if we shift it 1 unit up, it means the minimum will also shift 1 unit up. So our range for this function will be from y is an element from negative 1 to positive 3. And on this graph of y is equal to 2 sine 3x, our range becomes y is an element from negative 2 to positive 2, like that. So plus 1 up plus 1, it gives us the interval there of the range. Now, with that being said, I want us to look at the questions. You will do it later on at home. In the diagram below, the graphs of f of x is equal to tan x and g of x is equal to 2 sine 2x. You can see that this question is related to what we were doing there. When we found the general solution, we are able to see that. So we write down the period of g. So the period of g, you are able to see from the sketch. It starts here up to 0. So if you check, that's a complete cycle. So the period is 180 degrees. We have to calculate the value of k. The value of k is the y-intercept at that point, A. And remember what we said. A and B are 2 points of intersection of f and g. So f is equal to g and g is equal to f. So we have the value of x here. So we evaluate f of 60 degrees, for example, which becomes tan 60 degrees, and we know the value of tan 60 degrees. It gives us square root 3. Hence the value of k will be square root 3. We get our 1 mark there. The coordinates of B is that point there where the graph of f and the graph of g are intersecting. This is 60. If you look at the graph, this is at about negative 120 degrees, and the y value will be the same because that's the same y value. It will be square root 3 that we got in 6.21. We have to write down the range of 2gx. Remember, what is the range of g of x now? We are able to see that. You are able to so it means our maximum will be positive 2 and our minimum will be negative 2. So because we have to find the range of 2, so we are multiplying the range by 2, so it becomes negative 4 and 4, like that. We get our 2 marks. Question, or we use between negative 4 and positive 4 if we use the inequality notation. Now we want to find a region where g of x plus 5 degrees is less than or equal to f of x plus 5 degrees. Now, in the interval between -90 and that one. So there is the point of intersection. If you look at the original function, these will intersect at -60 degrees, and we do not have the value there, but it should be negative square root of 3. Now, if this is -60, you are shifting this point, it's a plus 5 degrees to the left. This other one, you are able to see that it's 0 degrees. You are shifting this point 5 degrees to the left, which means the interval will be between -65 degrees and -5. That is when the graph of G is above, the graph of F is above the graph of G. So we get a negative. So the graph of G is above the graph of f of x or equal to. So you are able to see it's between those 2 points there. We have to determine the values of p for which sine x cos x equal to p will have exactly 2 real roots in the interval between -180 and 180 degrees. So let's look at this. How do we do it? We have sine x cos x equals to p, and then we are saying, remember we got our maxima interval, so this becomes 4 sine x cos x is equal to 4p using the notation, but from there I know that 4 sine x is the same as 2 sine 2x, and this will give us 2 sine 2x is equal to 4p. We then divide both sides by 4 and we get plus or minus half, and then that's how we get our solutions there. We move on to the next one. Trigonometry in 2D and 3D. That is when we are looking at our 2D problems and 3D problems, our elevation, our angle of depression, as well as our angles of elevation. We have to look at those. Now we are saying, whenever you are dealing with 2D and 3D problems, you always have to state in which triangle you are working with. You redraw the triangle where you have most information, as well as which will help you to find whatever you are looking for. We identify common side, and then we do not forget about our trigonometric ratios. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Now, the sine rule, we know both versions. Where sine A is on the numerator, we have to, in most cases when we are supposed to find an angle, let's make the sine of an angle above and the length of the side as a denominator. And then we also have our cosine rule, our area rule. Now, when do you use our sine rule? When we are given 2 sides and a non-included angle, or when you are given more than one angle and a side. We also have to use the cosine rule when given 2 sides and an included angle, or when you are given 3 sides. Now, the area rule when you are given 2 sides and an included angle, and we are able to use our sine rule, cosine rule, and area rule to solve such triangles. With that being said, we are given a question, and I'll give you 3 minutes to answer only 8.1. You can try 8.2 if you finish early. Welcome back. Now, if you look at our question there, it says in the diagram below, T is a hook on the ceiling of an art gallery. Points Q, S, and R are on the same horizontal plane from where three people are observing the hook T. Now, we are supposed to, the angle of elevation from Q to T is X. Angle of elevation, we look up. Depression, we look down. Now it says QSR is 90 degrees plus X, QRS is X, and QR is 5 units. And TS is equal to SQ, those are equal. Prove that QS is equal to 5 tan X. QS is equal to 5 tan X. So how do you answer this question? I will only do that one, and then the rest you will have a look at them later on. It says, so remember, which triangle is going to help you get QS? So if I look at that one, it will be triangle QST. Redraw the triangle. So I'll draw triangle QSR. In triangle QSR, I will have, draw it so that you are able to see what you have. I'm able to have my S, my letter S, my Q, my R. The length of QR is 5. The angle S there, it's 90 plus X. And the angle R there, it's going to be X. As you can see there, we want QS. Once we get QS, we are also able to get TS because QS and TS are equal in length. So, using that triangle, you are able to see that this side QR, I'm given its length and it's opposite that angle. The side that I want, its QS, is opposite angle R. So I can use the sine rule. So QS over sine X, which is our angle R, and QR over sine angle S. Our QR is 5 units. Sine 90 plus, when I apply the reductions there, I'll get 5 over cos. And then from there, I want to make QS the subject. I cross multiply if I want, and then I'll get cos QS is equal to 5 sine X. So from there on, I divide by cos X, and this will give me my answer as 5 tan X. So 8.2, the solution, again, we have to draw the triangle. And then from there, we work with our triangle. We have to show that QT is that. So you are using triangle QTS, and then apply the sine rule, and then you will get the solution as such. Where there is tan, we put sine over cos X, and then we will get 5 sine X times 2 sine X all over sine X, and this will now give us 5. One of the sine X divides, then we are having 5 times 2 sine X, it will give us 10 sine X. 8.3, you can also use the cosine rule if you want. You apply the cosine rule, it still is going to work, and then we get our answer there as 10 sine X. But this one, I think it's a bit long. We rather use the first one, but if you are comfortable, you can use this one. We move on now to the last part. We are supposed to calculate the area of triangle TQR. TQR, TQR. The area, and we have the length. We have the length of QT. We apply the area rule, and this will give us our answer as 9.93 square units. Common mistakes. and errors that we make. We write amplitude as a negative. Remember, it's the magnitude. It always has to be positive. We confuse amplitude with period. Amplitude, remember, minimum to maximum, the magnitude. And then the period, it's what it takes to complete a cycle. And then we also make assumptions. If it's not said that they are on the same horizontal plane, you can't just decide. The diagram has to say, or the statement has to say. Incorrect simplification. Whenever we are doing our reductions, let us use brackets so that we know the reduction comes with its sign. If it's negative sine x, write negative sine x. Do not just write sine x. If it's sine squared as the reduction, you have to show that it's negative sine x all squared, then it gives you a positive sine x squared. Working with more than one triangle on 2D and 3D problems, remember you redraw and then you work. Using a calculator when the question states clearly that a calculator may not be used. And then we move on to Euclidean geometry, our theorems. Please, let's know our theorems and the diagrams that are associated with them. We have our theorems that are associated with chords and centers. We have our theorems that pertain to tangents and and then we also have the ones that are associated with cyclic quads. We must know all those theorems, 3 groups. We know the theorems. Now, these are theorems that we should know their proofs. They are examinable. The line drawn from the center of a circle perpendicular to a chord bisects the chord. The diagram associated, the line drawn from the center of a circle that bisects a chord is perpendicular to the chord. The angle subtended by an arc at the center of a circle is double the size of the angle subtended by the same arc at the circumference. Now, the opposite angles of a cyclic quad are supplementary. Please, you must refer to examination guidelines for the correct statements and reasons. How do you write the shorthand, especially when it comes to this cyclic quad? People just write exterior angle of a quad. If cyclic is not there, then the reason is not correct. Let us do the right thing so that we get all the marks. The angle between a tangent and a chord of a circle drawn from the point of contact is equal to the angle in the alternate segment. That's our tan chord theorem. And tan chord theorem, when we write a reason, we say tan chord theorem. But when you are proving a theorem, you can't use it to prove itself. A line drawn, these are the ones for grade 12. That's our proportionality theorem. Then we have our similarity theorem. There are 7 of them. And please, I'll encourage you, once the 10 minutes reading time is over, please go to the theorems and do their proofs as fast as you can, because they will be still fresh in your head before. Because remember, if a theorem, proof of a theorem, the first one is 5 marks for the grade 11 theorems, and the one for grade 12, it's about 7 or 6 marks. That's about 11 marks that you are guaranteed of getting. And remember, paper 2, you're using a booklet. You go there, you start with proving the theorems, you are done, you can go to the other questions. You'll be knowing that you have 11 or 12 marks in the bag. Now, remember, whenever you're proving a theorem, construction or a construction statement is required. As you can see, we use broken lines for our constructions. And we are saying we answer the theorem questions first before any other question, while it's still fresh, because you'll be guaranteed of getting those marks. We move on. Remember, this one, the construction that you make is that one, and you are supposed to prove that AP is equal to PB. The moment you have that construction, you get 1 mark. The moment you do a construction like that, you have 1 mark. And then the steps follow after. Now we have the next theorem. Angle at center, we know the construction that we make, and we use the exterior angle of a triangle to prove the theorem, and angles opposite equal sides to prove the theorem. That is the version that is normally examined, but remember the other versions, please have a look at them. We can't say this is what is coming, which one is not coming. Let's look at everything and know everything. Now, our cyclic part, we know that if we are supposed to prove that B plus D, remember the construction has to be OA and OC, and then we name our angles O1 and O2, and we use the angle at center being 2 times angle at the circumference, and then we show that B plus D is equal to 180 degrees. For our turn chord theorem, the construction that we make, we form another point there, we call it F. So it's diameter B or F, and then we join E to F. We name our angles 1, 2. We name our angles 1, 2. This one, we know it's 90 degrees, turn perpendicular to the radius, so B1 plus B2 is 90 degrees. And then we also have E1 plus E2 being 90 degrees. This is an angle in a semicircle. And then from there, you are able to see that E1 will be equal to B1. These are angles in the same segment because they are subtended by the same arc, DF. And then if these two are equal and these two add up to 90 degrees, it follows that this one will also be equal to that one. We move on. We start by construction. And then our proportionality theorem, we know that we construct our height, perpendicular height from AP to the third vertex. We construct another height, H1, H2, and then from there we join B to Q. We also join P to C. The moment you do those constructions, you get 1 mark. And then from there, we are supposed to prove that AP over PB is equal to AQ over QC. But remember, they can ask you about the other ratios that are also possible here. You must be able to do that. And then our similarity theorem, that angle, that one, hash, and you'll be given that this angle is equal to that one, equal to that one, hash. The construction that you make, a point there, this GH. So AB is equal to DG and AC is equal to DH there, and then you join G to H. How many triangles are we having now? Here we are having 2 triangles, and then we have to prove that GH is parallel to that so that we are able to apply the proportionality theorem there, and then we get our answer. The moment you do your constructions, you get 1 mark there. Now, let us look at, for Euclidean geometry, all theorems and converses for grade 11 and earlier grades should be known. Visualizing is important in Euclidean geometry. You have to see it in order for you to answer the questions. Geometry learned in lower grades is still applicable. The geometry of straight lines, the geometry of triangles, the geometry of quadrilaterals, we must know them all. The midpoint theorem is a special case of proportionality theorem, and we are saying the converse of proportionality theorem and similarity must be known. And then we also must know Pythagoras theorem and its application there. Now, let's check. the geometry of straight lines. If I have two parallel lines and a transversal line, I can have my corresponding angles, my co-interior angles, and my alternate angles. So my alternate angles are equal. I have A3 being equal to B2, A3 equal to B2. You can see it's either I form letter Z or letter N, and then A4 is equal to B1, A4 is equal to B1. There I have it. This is equal to that. This is equal to this. We must be able to see these once we have parallel lines. Corresponding angles, we know that they have to be on the same side. We are told A1 is equal to B1. You can see the letter F there. And then A2 is equal to B2. Again, same side of the parallel lines. And we also have A3 equals to B3 and A4 equals to B4. And we also have our co-interior angles that add up to 180 degrees. And also the types of triangles. Obtuse angles, one of the angles must be more than 90 degrees. Acute angled, all the three angles are acute angles. They are less than 90 degrees in size. And then isosceles triangle, we have a pair of adjacent opposite sides being equal in length, and we have got a pair of angles, opposite equal sides that are equal. Equilateral triangle, all the sides are equal in length and the angles are all 60 degrees. A right angled triangle is a special type of a scalene triangle which obeys theorem of Pythagoras. And then we also have the sum of angles in a triangle is 180 degrees. Then we have the exterior angle of a triangle is equal to the sum of the opposite interior angles there. And we are able to see that. We have cases for congruency where we have angle side angle. If I have two angles, the orientation does not matter, but the order of how we name the angles becomes important when we are naming congruent triangles. We also have side, side, side. All the three sides are equal in length. We can use that. And then we also have the hypotenuse, right angle, hypotenuse, and the side. When we have a right angle, the hypotenuse, and a common side and a hypotenuse, we are able to use that. And then we also have side angle side, it's a side. Then we have an included angle. Then we use that. And then we have the midpoint theorem, where a line drawn from the midpoint of one side of a triangle to the second side of the triangle, then it will be parallel to the third side and its length will be half the length of the third side. So if this was 14, this becomes 7 if these are midpoint. Now let's quickly answer those questions. I will give you 4 minutes to answer those. Welcome back. Now, here is the hint that I'm going to give you. Once you read the information, PON is the diameter of a circle centered, or as you are reading, you are visualizing. So if it's a diameter, it means somewhere I must have a right angle, and I can indicate this is a right angle. I also have a tangent. There is my chord subtending an angle. So from there, I know that this one will be 66 degrees. Add to the diagram so that it helps you to see. If I check, OR is parallel to PM, so this will also be 66 degrees because these are corresponding angles. And then if this is 90, I have 66. This one becomes the third angle of a triangle. It will be 24 degrees. And then from there on, I'm also able to see that which other angle I can get. I can get O1. O1, these are angles in a straight line. And this is 114 degrees. And then I am able also to see that triangle ORN, this becomes an exterior angle. So I'm able to see that this is equal to that, which means angle R is equal to the angle N1 plus N2 there to help me get the answers. Once I've done this, I am able now to answer the questions. The first one, I'm supposed to find P. P, I already have a value there, and I now know how I got it. So P is equal to 66 degrees. Reason, tan cot theorem. I also have M2. M2 will be equal to 90 degrees. This is an angle in a semicircle. Statement, reason. I have 4 marks so far. N1. N1 is 24 degrees using sum of angles in a triangle. So here both the statement and reason must be correct because it's 1 mark. Sum of angles in triangle. O2, remember O2, we said O2 is 66 degrees. These are corresponding angles equal because we have PM parallel to OR. Remember, for corresponding co-interior alternate angles, we have to always mention our parallel lines. N2. So I said my starting point will be N1 plus N2 plus R is equal to 114 degrees. But I have to mention that N1 plus N2 is equal to angle R, angles opposite equal sides, because these are RD. From there on, I can add the 2, then divide so that I get the other angle as 57. From there on, this is 24, 57 minus 24 will give me the angle as 33. So there is the other alternative. 180 minus, using the sum of angles in a triangle, we get 114, and we know that R is equal to N1 plus that one, and then from there on we get our N2 as 33 degrees. Now we have the question, we are supposed to prove the theorem. We construct OK and OM, and then we find angle J and angle L, and then from there on we use O1 and O2, we add them together, 360 degrees angles around a point, but we've used angle at center being twice angle at circumference. We then divide by 2, and then we show that. So this is opposite angles of a cyclic quad. It can be asked this way. We move on to the next question. We are given that our in the diagram, O is the center of a circle, OD bisects that one. We have to prove that the theorem that states that the angle at center of a circle, the line from center of a circle that bisects a chord is perpendicular to the chord, that is OD is perpendicular to AB. So the construction that we make, we form a triangle and we prove that the two triangles are congruent, and then the reason will be side, 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 and then we use our angles in a straight line. But because the two triangles are congruent, it follows that D1 is equal to D2. Therefore, if the angles are in a straight line, they add up to 180. And if the angles are equal, 180 divided by 2, it means D1 is 90 and D2 is also 90. Then we get full marks there. Moving forward, there is another easy question. We are having 9.1. Give a reason why ST is equal to that. These are tangents from a common point. And then 9.21, calculate with the size of angle S2. From there on, we said this is equal to that, tangents from a common point. We are having triangle SRT. So in triangle SRT, you are able to see that the sum of angles is 180, so it follows that R2 is equal to S2. So this will give us our S2 as 180 minus 78 divided by 2, which gives us 102. We then divide by 2 and we get our answer as such. We get our S2 as 51 degrees. S3, we are going to use our S2 plus S3 is equal to 93 degrees because these are the exterior angle of a cyclic quad is equal to the opposite interior angle, and we have the size of S2, we have calculated it, and then we get S3 as 42 degrees because that will be 93 minus 51 to give us 42 degrees. Statement and the reason, we get our answer there. Now you will go and answer this one at home. It's November 2021, question 10. You will do it when you get home, but here are the solutions, but you will do it when you get home, and then we get the answer as such. Another activity from the November 2022 question 10, it applies a lot of grade 12 Euclidean geometry. Please have a look at it when you are relaxed. You can take a photo, and the solutions for 10.1, the solution for 10.2, and the solution for 10.3 as well, where we are using our similarity, and then we use the proportionality theorem, and then we equate those because they all both refer to AS, and then we are able to get to prove that. And then from the February-March 2016, paper 2, question 10, the proof of our similarity theorem is asked in a different way. Just go through it as well so that you are able to remember the proof of the similarity theorem, and then we get our solution as such. Now we have come to the end of our lesson. Please, this will refer to all the other sections of the question paper. You always analyze the given information to identify what can be used. You always remember that diagrams are not drawn to scale, so you cannot start measuring. We must use the diagram effectively, add information to the diagram, make construction, use color. It will help you a lot. Label correctly the notation that you are using for angles, lines, equal sides, equal parallel sides. You should add those to the diagram. They will simplify and make it easier for you to see what you are dealing with. We write given information in the diagram, and as you get answers, add them to the diagram. It will make your life easier. We have to draw in all additional lines so that a clear picture of the question can be seen. We cannot use follow-up answers to answer previous questions. If you have to show that x is 7, and then in the next question it says, if given that x is 7, you must determine x first and not use the one that is in 1.2 or 3.2 to answer the first question. The properties of triangles, quadrilaterals must be revised thoroughly, as well as the use of color is encouraged, and we must refrain from making assumptions. If it's not stated that it's a diameter, we can't assume it's a diameter. Good luck for paper 2 examination and all the best. I thank you. Let's keep on practicing. Have a good afternoon.